Review number 3, common questions. Yuri's already chirping in my ear. I better get going. There's a lot more topics in this one, so I'm gonna try to make the video not last too long, but you might need to pause it and watch different parts as you do different questions. So first, some quick review of some repeatable questions that show up a lot, and then some new ones mixed in. Greenhouse effect. Short waves go in, and remember, violet and blue are the shortest. Long waves radiate off of the Earth. So the Earth absorbs. Dark things absorb more. Light things reflect more. This is not a reflection. This is a re-radiation. This is called terrestrial radiation. Greenhouse gases trap the terrestrial radiation, which is infrared heat. Carbon dioxide, methane, and CFCs, also water vapor, all are really good greenhouse gases for trapping that radiation. Sun fusion crossword puzzle. Light elements turn into heavier elements, hydrogen to helium. Young stars have more hydrogen. The older a star gets, the hydrogen goes down because it's getting used up and turned into helium. Yuri, I'm going as fast as I can, man. Jovian are the Jupiters. Earth are the terrestrials. ET phone home. The Jupiters are gassy. They're big. They've got a lot of moons. Some have rings. They're big. Earth made of rock. So they're the coolest planets. Sorry, Jovians. Pretty straightforward. Red away. Red shift. When the lines, the spectral lines, if they're getting shifted towards the red side of the spectrum, that indicates that a star is moving away from us or from the point of view. Redshift, Doppler effect, cosmic background radiation all go together. They support the Big Bang. They support the idea that the universe started out really tiny and has just expanded out in all directions and still is. September leaves need raking. Coriolis, Foucault, spin. That shows that the Earth rotates on its axis. All right, some new stuff. If you take all 4 of these containers, it does not make sense. It's not. It's counterintuitive. But this container, and now my drawing skills aren't great, but if they were just evenly poured in and you had round particles, all 3 of these would have the same amount of empty space. If you took a swimming pool and you filled it up with baseballs, golf balls, and bowling balls, one of a pool of each, they would still have the same amount of empty space in all of here. It doesn't really make sense. You wouldn't think that that's the case, but round particles fill up stuff the same. So that's called porosity. How much empty space? If I was going to fill up each of these containers, this one would have the least amount of space because it's like a puzzle and all the pieces are fitting in. These 3 would have the same empty space. But that's different from what's called infiltration. Infiltration is how fast does the water get in. Bigger particles have bigger empty space, so this is going to have the highest infiltration. As the particles get smaller, the infiltration is going to get slower. This would have low infiltration because these particles are really small, and since this is like pieces of a puzzle fitting together, it's going to have the lowest. So these 3 take the same amount of space up, but the biggest particles let water into the ground the fastest. Diagrams of the Earth, Moon, and Sun. When the Moon and the Sun line up, that's when you have the highest high tides and the lowest low tides. But wherever the Moon is, that's where the high tide is on each side of the Earth. The Earth spins, and that's why high tides come back every 12 hours. It takes 6 hours to go from high to low because the Earth is spinning. Well, I should really show the Earth spinning this way in the diagrams. So since the Earth is spinning, it goes 6 hours from high to low and another 6 hours back to high. Now the Sun is down here. So the Sun pulls a little bit. The Moon actually pulls more because it's closer than the Sun. If they don't line up, high tide is still wherever the Moon lines up with the Earth. It's just not quite as high, and the low tide's not quite as low because now the Moon and the Sun are kind of fighting against each other. If you take some different hills, steep hills have faster runoff. The rivers would flow faster. There's less infiltration. Infiltration is the water getting into the ground. Okay? a gentle hill is going to have more infiltration and less runoff. Now, if the ground is not saturated, if the water table is lower, you're just going to have more infiltration. The water can soak into the ground better. So the flattest, lowest groundwater is going to have the most soaking, which is called infiltration, and the least runoff, which is called a river. So those are those. Now let's just go through some different questions that I don't have sticky notes for every single one, but just to explain some things for you to try to work on this on your own. Your ESRT, page 8 and 9, I guess I have to pull this back up for this question. How long have humans been around in Earth's history? Very common question. So let's just remember a couple of things. This is all of Earth's history right here. This last piece is the Cambrian, comes all the way back down into here, and all of this detail right here is actually squeezed into that last part, and humans have showed up in this part, which is actually squeezed into this part right there. So to figure out the percentage of that whole timeline that humans have been around is a common question. Dew point, relative humidity. What's the dew point? They want a dew point, and they want the dew point. So we got to work on this chart. What else did they give us? They gave us the air temperature is 28 and the relative humidity is 47. So remember, you can go back and forth between the charts. Air temperature is dry bulb temperature. It's 28. So I would look at the 28. They give me the relative humidity. So you've got to use the charts to go to the relative humidity and then go back up to that other chart and try to find your dew point. Which two mantle hot spots are located at mid-ocean ridges? Page 5. It's another ESRT questions. Look up the hot spots, look up the mid-ocean ridges, and I don't think you actually need any help with that. If you remember that you go to page 5 for stuff like that. How many years ago were South America and Africa located south of the equator? You might have forgot that you can do this with the ESRT, the history of where the continents used to be. The rhymes just come to me. So there's North America. It's colored in for us. South America, you know what I mean? South America, Africa, Asia, Antarctica. Where did the continents used to be? You look over here and it tells us how many millions of years ago continents were in different locations. Parallel scratches. Which agent of erosion makes parallel scratches? Go to your review book, Weathering and Erosion, super common question. Not in the New York State rock record, another ESRT question. So which fossils are not in the New York State rock record? Easy to overlook this column right here. New York State does not have rocks in the Paleogene. New York State does not have rocks from most of the Jurassic and some of the Cretaceous. New York State does not have any rocks from the Permian. So fossils that are in those time periods, you can't find in New York State. These are really difficult. Stream drainage patterns, you could look that up in the review book. You have to try to match up which of those 4 patterns would match on top of a volcano. So if a volcano is cone-shaped in all directions, how would the water flow off of that? How would the rivers look from the top of a volcano? Water goes fastest on the outside of a curve and slowest on the inside of a curve. Erosion is where the water's fastest. Deposition is the inside. Looking up rocks. This is just your ESRT on your rock charts there. This is one that we need to spend more time on in class. What location can intensely metamorphosed rocks be found? If it's a New York State question, you go to New York State. Okay, here's New York State rocks. Intensely metamorphosed rocks. As I read through all of this, I've got to find intensely metamorphosed. Intensely metamorphosed. I've got to look up in the descriptions here and find those symbols and then find where in New York State are those symbols. So different rocks can be found in New York State using that map. Correlating, matching up the rocks by age, definitely shows up a decent amount of time. Compared to the white sandy region, the vegetative region is, obviously more humid versus less humid. I think that's common sense. Which one's going to absorb more sunlight and reflect more sunlight? White sand is a really good reflector of sunlight. Trees help to absorb sunlight. All right, so hopefully those questions make sense. Once you've watched the video in class, you can ask me in class to go over more of these concepts before you turn this in, but I really need you to watch the videos first to get through most of these questions, I hope. Let me know if you have any questions. How did I do, Yuri?